Now I'm going to give you two examples of solving limits when if the straight plug-in of the limit would result in indeterminate form, meaning 0 in the numerator and 0 in the denominator. In our first example, we have x cubed minus 8 over x cubed plus x squared minus 6x. We need to factor this. The numerator is the difference of squares. So we get x minus 2, x squared plus 2x plus 4. And in the denominator, we can just factor out an x. So we're going to get x, then x squared plus x minus 6x. We can factor the denominator one more time. X minus 2 and x squared plus 2x plus 4 can't be simplified on the numerator any further. Then we have x minus 2, and x plus 3. What we've now done is we can cross out one of these terms from the numerator and denominator. This will allow this 2 to be plugged in and not get 0 on the denominator and a numerator. So if we plug our 2 in, we should have 2 squared, which is 4, plus 2 times 2 is 4, plus 4, all over 2 times 2 plus 3. So we have 12 over 2 times 5, which is 10. So our final answer is 6 over 5. So one way to get out of indeterminate form and find the value of the limit is to factor both the numerator and denominator to find a term to cancel out. Another option we'll look at in our second example is if you have, once again, indeterminate form, plugging this 0 in will result in 0 over 0, but you have this radical here. And what we can do is we can rationalize either the numerator or the denominator, in this case, the numerator, and see if that helps to be able to plug this 0 in without getting indeterminate form. To rationalize the numerator, we're going to multiply each side. So we have the limit as x approaches 0 of 2 minus 4 minus x over x, and multiplying each side by 2 plus 4 minus x over 2 plus 4 minus x. Multiply out the numerator here, we're going to get 4 minus 2, 4 minus x, plus 2, 4 minus x, minus 4 minus x. And the denominator, I'm not going to multiply the x in, I'll just keep it like this. These two terms cross out, and the 4 minus 4 crosses out, so we're left with the limit as x approaches 0 of x over x to 4 minus x. Once we've done all those cancellations, the x and the x can cross out, meaning that plugging 0 in will not give us 0 over 0. This gives 1 over 2 plus the square root of 4 minus x, which is 1 over 2 plus the square root of 4, which is 1/4. And that's the second way that when you have a limit in indeterminate form, you can solve the equation to find the value of the limit.